Hello everybody. Today we're going to be talking about significant digits, and this is mostly for OSSD students. However, it does apply to most high school students in general. The first thing I'd like to note is that significant digits can also be written as significant figures, and the shorthand for significant figures is sig figs. So if you see the word sig figs, then you know that I'm talking about significant figures. So the 5 main rules that we're going to be talking about today are for identifying significant digits or significant figures. The first rule is the non-zero rule. If a number is non-zero, then it is significant. So this number here, 835 centimeters, it has 1, 2, 3 sig figs. So that'd be 3 sig figs. This number right here has a 2, 5, 6, and 7. So that has 1, 2, 3, 4 significant figures. These are all non-zero numbers. The next significant figure rules is the zeros between digits rules. So any zero that's between 2 digits is significant. For example, 903 meters. This zero is significant because it's between 2 significant figures. So we have 3 sig figs. This number over here, 1.507 meters per second, has 1, 2, 3, 4 sig figs. The next rule is the leading zeros rule. Any leading zeros are not significant. So for example, this decimal here, 0.000506, the only digits that are significant are the 506, so this number will have 3 significant figures. Everything in front can get thrown away. And this number right here, 0.3, this only has 1 significant figure, the 3. The fourth rule is the trailing zeros rule. Any trailing zero is significant if it's in a decimal number. For example, 0.900, we have 1, 2, 3 significant figures over here. These trailing zeros are significant. It's not significant if it's not in a decimal. For example, 25,000, the 2 and the 5 are significant, so this is 2 significant figures. Okay. The last rule is the exact numbers rule. And the exact number rule says that if a number is exact, for example, like a number of electrons over here, it has infinite significant digits. So despite this looking like it has 2 significant figures, it actually has an infinite number of significant figures. Why do we do this? Well, significant figures and significant digits are used for talking about precision in physics and science problems. So what we're doing with this is when we're doing any calculations, which we usually do using formulas, we're talking about rounding our final answer. So you need to identify what significant figures you're given in a problem and then how to round your final answer to the appropriate number of significant figures. So your final answer should be rounded using the lowest number of significant digits. Here's a cat. He's very cute. So let's take a look at a problem using this. Here we have this question. It says, given P equals 3.266, Q equals 700, R equals 6.80 times 10 to the 8, and S equals 0.005020, find the value of each expression and report your answer using significant digits. We have 1, 2, 3, 4 questions to answer with this. So what you should do is you should take a minute and you should try and calculate this, each of these questions, and round your answer to the appropriate number of significant digits. Before we begin, we should do a little bit of an analysis on this question here. So we're given 4 pieces of information up top. Our analysis is going to look something like this. We take a look at P. We can say that P has 1, 2, 3, 4 significant figures. We can see that Q has 1 significant figure, just that 7. We can see that R has 1, 2, 3 significant figures. Remember, we ignore everything in the times 10 to the power of 8 here. And we also have S having 1, 2, 3, 4 significant figures. So this is going to determine, or these numbers right here, the number of significant figures, are going to determine how many significant figures are found in our final answer. So if we take a look at A, we can see that A is going to be P plus Q. Well, Q has 1 significant figure, and P has 4 significant figures. Therefore, A will only have 1 significant figure as well. For question B, we have P, R, and S. So P, R, and S, the lowest number of significant figures is R. Therefore, P will have or B will have 3 significant figures as well. Taking a look at question C. C has a P and an S in it, so we have a 4 and a 4. Therefore, C will have 4 significant figures. And finally, question D, well, D is a constant number divided by S. S has 4 significant figures. Therefore, D will also have 4 significant figures. So after we do our calculations, we're going to have to round our answers to look like this. A will have 1, 3, 4, and 4 significant figures. So let's do that math. Making sure to show all of our work, we should be substituting in all of these values in our first step. So P is 3.266 plus Q is 700. So if we put that in our calculator, we should have 700 plus 3.266. Our answer is going to be 703.266. 703.266. And then we're going to have to round our final answer to 1 decimal place, or having 1 significant figure. To do that, we're just going to take the leading 7. So our answer is A equals 700, which comes across as a little bit strange, because clearly when you add these two numbers together, it's not 700. But when you're taking into account significant figures, it's okay for this 3.266 not to really do anything. The next thing we're going to do is this question B down here. Substitute in our values. So P is 3.266 divided by R is going to be 6.80 times 10 to the 8, and S, well, S is going to be 0.005020. If we put this into our calculator, we're going to get 3.266 divided by 6.80 times 10 to the 8 plus 0.005020. And our answer will be, as shown on the calculator here, B equals 4.802941, etc., times 10 to the negative 9. Now, if you remember from our analysis, B is going to have 3 significant figures because R has the fewest number of significant figures in this calculation. So, rounding this, we should get 4.80 times 10 to the negative 9 as our answer for B. There's our solution. Coming over here, we're going to be taking a look at question C. C has a square root in it, and that's not actually going to cause us any problems. We can write C equals the square root. P is 3.266 divided by 0.005020. So the first thing we're going to do is calculate that square root, 3.266, and we're going to divide this by 0.005020. And we're going to get an answer, C is equal to 360.001552. P has 4 significant figures, S has 4 significant figures, so our answer will have 4 significant figures as well. So C is going to equal 360.0. That's our final answer. And then finally, for question D, D is equal to 200 divided by S to the power of 3, 0.005020 to the power of 3. We're going to put that in our calculator here. We have 200 divided by 0.005020 to the power of 3. And we get an answer of 158095252. But keeping in mind significant figures, we need to round it to 1, 2, 3, 4. That's 4 significant figures. So we should have 158. The last digit is going to go up to 1 because the next number in the sequence is 9. And then we have to continue on with all the other zeros. So 0, 0, 0, 0, 0, 0. This is fine. Another way of writing this would be D equals 1.581 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is actually better in terms of using scientific notation. So that's everything that you need to know about significant figures for OSSD and most of your science courses. If you have any questions, just leave them in the comment section below, and make sure to like, comment, and subscribe.